After finishing the modeling of the teapot and the jug, let's prepare the scene by placing the two objects in the correct position. Let's set the front view. Let's reactivate the Disable Selection icon for the reference collection and select the photograph. Press the G and Z keys and move the image upwards. Make sure to align the base of the teapot with the red horizontal line of the X-axis. Turn off the jug collection. Turn on the teapot collection and double-click the collection icon to select the objects it contains. Press the G and X keys and move it to the right, the complete model, making sure to align it as closely as possible with the reference teapot. Now let's switch to the top view and turn the jug collection back on. Move the teapot along the Y-axis downward so that it separates from the jug. A measurement of -17 centimeters should be sufficient. Let's return to the front view and make sure that the 3D cursor is at the origin of the global axis. If it's not, press Shift-C to position it correctly. In the outliner, create a new collection and name it Base Set. In the 3D view, press Shift-A and from the menu that appears, choose Mesh, then Plane. This will be the support plane. Set its size to 100 centimeters for both the X and Y axes. Switch to a perspective view and, with the plane selected, press Shift-D followed by Enter to duplicate it. Press RX90, then Enter to rotate the copy 90 degrees on the X-axis. Press GY to move the vertical plane behind the two objects. A distance of 25 centimeters should be enough. This will be the wall. For better organization, let's rename the horizontal plane to Support Plane and the vertical one to Wall in the outliner. Let's vertically split the 3D view into two windows and set the one on the right to UV Editor. The original photograph we used for the previous modeling steps should immediately appear. If it doesn't, you can add it with a simple drag and drop or by selecting it from the Browse Image to be linked command. Set the 3D view to front view. In the outliner, turn off the reference collection and activate the scene collection. In the 3D view, press Shift plus A and select Camera. Press the key combination Ctrl-Alt-0 on the numeric keypad to quickly position the camera exactly where you are. To replicate the view we see in the photograph, in the Properties window, open the Camera tab and activate the panel. Background Images. Click on ADD Image and then on Open. Navigate within the File Explorer window that opens until you find your reference file, then double-click to select it. Change the display mode to wireframe. Now the framing doesn't match at all because our camera has a different resolution from the photograph. To align them, we need to change the resolution currently used by our camera, setting it to the same pixel dimensions as the reference photograph. So let's open the Output Properties tab, and knowing that the photograph has a size of 1365 by 1080 pixels, a value you can easily find by accessing the file properties. Set the X and Y fields in the resolution channel to the same values used by the reference image. 1365 for X and 1080 for Y. Now, with the camera selected, use these shortcuts to interactively manage the camera's position. After pressing the G key, hold down the Shift key to have greater precision when moving, and move the mouse to better position the camera. Press G, Z, Z in sequence and move the mouse up or down to get closer to or farther from the objects. Press R, X, X in sequence and move the mouse up or down to rotate the camera vertically. Press G, Z to raise or lower along the vertical Z axis the camera. Another parameter we need to check is the camera's focal length, which is essential to achieve the final result. In this regard, it's useful to keep in mind that in still life photography, longer focal lengths are often used, medium long ones such as 85 mm or 135 mm. This is precisely because they help reduce perspective distortion and provide a more compact and proportionate rendering of objects. Moreover, this type of focal length makes it easier to control depth of field, allowing for selective focusing and effective isolation of the subject from the background. So, once the camera is positioned to achieve a framing as consistent as possible with the reference photograph, we open the camera tab in the Properties window and set the focal length to 100 mm, thus increasing the value of the parameter, focal length. We repeat the camera positioning operations until we are satisfied with the result. Of course, achieving the exact same framing as the photograph is practically impossible due to numerous variables. Among these are the specific characteristics of the actual camera lens, such as distortion and perspective compression, the type of sensor used in the camera, full frame, APS-C, etc., any optical deformations in the original photo, and the precise position and tilt of the real camera. After several attempts, I found that positioning the camera with the following values for the location and rotation channels was effective. For location, x equals 5 cm, y is minus 170 cm, and z is 42 cm. For the rotation parameter, x equals 80 degrees, y and z are both 0 degrees. This configuration provides a shot very similar to the one in the photograph, even taking into account the inevitable differences due to the optical and perspective variables already described. That's all for this lesson. As usual, let's save the file incrementally. In the next lesson, we'll tackle the very important topic of lighting.